All right. Describe each item below. What is a factor? A factor of something is when you divide, there's no remainder, right? And the same works with these big things here too. So if we have the number 12, right? 6 is a factor of 12 because 6 times 2 is 12. And if I take 12 and I divide it by 6, I get 2, no remainder, right? And I think we talked about this in class, but you can factor every number down, and this includes polynomial functions too, into prime factorization. So I have 12, right? I know that 6 times 2 is 12, but I can break 6 up into 3 times 2, right? And then it works kind of in a cool way because 2 times 2 is 4, and I know 4 times 3 is 12, right? So these are all different factors of 12. They all can come down to prime factorization. What is a 0? How is it seen on a graph? A 0 is a solution to a polynomial, and it is also a root. Remember all of those words we had for that. And on a graph, it is also the x-intercept. You can see it on a graph because it's where it crosses the x-axis. What is a coefficient? How is a coefficient seen on a graph? So a coefficient is just a number that you are multiplying by a variable, right? For x, 4 is the coefficient, not x. 3z, 3 is the coefficient there. You could even have 1/4 t, 1/4 is the coefficient there. How is it seen on a graph? We talked about this in the last video. What that does in a graph is it is the vertical either stretch or shrink. Like if I have just an x squared like this, right? And then let's say that this point right here is 2, so this is 4, right? And that's just the graph of x squared. Well, what would happen if I put a coefficient of 2 in front of the x squared? Well, that's going to change that output of 4 to be 8. And then what that looks like when you graph it is it looks as if the 0 doesn't change. It looks as if I've just I've vertically stretched that graph. And if I multiplied it by a number less than 1, like say half, then it would look like I had vertically shrunk. Is that the right word? Shrunked that graph. I know that's not the correct word, but you know what I'm talking about. What is the multiplicity of a factor? That was where we talked about how many times that 0 occurs. And how do you see it on a graph? We talked about this in the very first question here, right? Where it depends on what the graph looks like at the point that that 0 occurs. So this first one here is x squared. Anything even is going to bounce off and go back. This looks like x cubed, and it has to be odd because it goes straight through. And this was the 1. Describes, oh no, that's not where we are. Where are we? Sorry guys. Okay. 10, describe the steps needed to write a polynomial equation from a description of that equation. So that's just what you've been doing. You can do that. Describe each item below and give an example using what we're talking about here. What is a complex conjugate? The complex conjugate is when you take your complex number, which has both a real piece and an imaginary piece, and you switch the sign. And the reason you do that is so that when you multiply them together, you can get rid of the imaginary number. So this would be the complex conjugate of 4 plus 3i would be 4 minus 3i. What happens when you multiply a complex number by its conjugate? What did I just say? We get rid of the imaginary number. So if I did this using an area model, this is kind of what we did in that last problem from the other video. 4 plus 3i, 4 minus 3i, here we get 16, here we get 12i, and here we get negative 12i. So perfect, right? Those are going to cancel. And then here I get negative 3i squared, but remember I squared is the same as negative 1. So I don't know if it wants me to finish this, but I'm going to go ahead and finish it. What we get is 16 minus 3 times negative 1, which is 16 plus 3, which is 19. Okay, so we can turn our imaginary number into a real number by multiplying by the conjugate. What is the standard form of a complex number? That is a plus bi. The way I think about it, where the a is the real, the b is the coefficient of the imaginary, and I is the imaginary. You can always think of complex numbers as being a point on a plane where you have the real. Instead of the x-axis, we have the real numbers. And instead of the y-axis, you have the imaginary numbers. Okay, and so if this 4 plus 3i would be 4 on the real numbers, and then it would be 3i on the imaginary numbers, and that number is going to be a point on the plane, as opposed to any other number. Any other number is going to be a point on a number line, right? You're going to say, oh, 3 is here, 2 is here, 0 is here, whatever you're thinking. But an imaginary number is going to be a point on the plane. It's not going to land exactly on the number line. What is the standard form of a complex number? That's that a plus bi. Why do we need complex numbers? So that we can take the square root of negative numbers. Okay. The square root of negative 16, well, that is going to be, what's the square root of 16? Is positive and negative, 4. You guys had a brain freeze. Positive and negative 4 times the square root of negative 1. Well, what we can call that is 4i, right? Let's see, what are we doing? Okay, so for the classwork, I'm just going to do a couple because they're all the same. And I want to make sure I have enough time to do videos of the other one. So find the polynomial of this. If zeros are 3, that means my factor is going to be x minus 3. It says it has multiplicity of 3 to the power of 3. If I have a 0 of negative 1, that factor is going to be x plus 1, multiplicity 2. And 0, that means for anything that's going to have a 0, I'm just going to put that on the outside, x. Because if I make x 0, you make x 0. You could say instead x plus 0 over here, but I mean, you could say x plus 0. Doesn't matter, but let's just do the x on the outside. Has multiplicity of 1, so that's just going to have that 1. And it says p of 1 is 4, so we're going to use this information to find our coefficient. Okay, so let's do it the way Ms. Stewart does it. Let's say I know I want my output to be 4. So when x is 1, and I want to find k, right? So if x is 1, that first one is just going to cancel out here. And then we're going to have 1 minus 3 cubed times 1 plus 1 squared. 4 equals k times 1 minus 3 is negative 2. Cubed is going to be negative 8. I think I'm doing this in my head. Please check me. 2 squared is going to be 4. So negative 32. So 4 equals k times negative 32. Divide both sides by negative 32. K is going to be equal to negative 1/8. Cool. So my equation is going to be p, it wants it to be p of x. All right, we can do that. P of x is equal to negative, that's important because that's going to show us which way it points, negative 1/8 x, parenthesis, x minus 3 cubed, parenthesis, x plus 1 squared. So it's going to be short and fat, right? And it's going to, well, what do we got? What's our degree? We have 1, 2, 3, 4, 5, 6. It's all going to point down, right? Because it's negative, so this side's going to be going down. And this side also is going to be going down. My zeros are negative 1, 3, and 0. Okay, So it has to come up this way. The -1 has multiplicity 2, so it's going to go back down like this. But then it's got to go up through this 0, and it's going to go straight up through this 0 because it has multiplicity of 1. And then 3 that has multiplicity of 3 is going to kind of do that. So this actually isn't a function because I drew it so it doesn't pass the vertical line test. But you can see maybe what it might look like. Let's see. And you can see, like, if you want to see maybe how tall it gets, you can always do this, you guys. If I know, like, this is going to be 1, this is going to be 2. What if I put 1 back in that polynomial? I can say, instead of putting, oh, we know that, duh. If we put in 1, we get 4 back. So this is going to be like 4 right here. And then what if you put 2 into that polynomial? You would get -1/8 times, let me get the calculadora up, actually. All right, I pause that, I put in the calculator, and I get 2 goes to like 2.25. So actually it's going to come down more and then do like that. But these are just sketches, you guys. So don't worry about getting it perfect. But this is kind of what it might look like. Let's see. Let's see how fast I can do this one. And then this little 16 will have to be the last one. I do have 3 minutes. Or less. Zeros are -2, so x plus 2, multiplicity 2, x minus 1, multiplicity 1, and x minus 5, multiplicity 1. H of 2 is -4, so -4 equals k times 4 squared is 16. I put in 2 here, 2 minus 1 times 1. I'm not even going to put that in there. 2 -3 times -3. So that's going to be -4 equals k times, this is really quickly in my head, -48. Divide both sides by -48. K equals a positive 1/12. 1/12, I think. So this is in my head. So the actual equation is h of x equals 1/12 times that. Okay, that top row is the equation. And if I want to quickly sketch it, my zeros are -2, 1 and 5, 1 and 5. Okay, these are, and it's positive 1, 2, 3, 4, positive 4, so both ends are going to point up. The -2 is kind of squared, so it's going to do this. Then it's going to, oh, what happens if I put 0 in? I get 2 squared is 4 times 5 is 20 divided by 12, approximately 2. So it's going to come back here, go through the 1, and then go back up through the 5. Something like that. You can put in, if you want a better graph or a better sketch, you can put in any of these numbers in between here and see like how far up or down it would go. But feel free to do that. 17, 18, 19, and 20, you guys, I think they're just all the same things, and I'll be more than happy to help you out if you bring a question to class. But try it first, please. Try to put, oh, maybe I should do 20. Maybe I'll do a separate one with 20 because it looks a little bit more difficult. Okay, so one more with 20, but I don't have time on this one.